So now that we've defined this three-phase model of soils, we can use it to then define more complex parameters. And the first one we're going to look at is bulk density. Now, bulk density is the total mass of the soil divided by the volume that mass takes up. So bulk density is often given the symbol rho. And that is equal to the total mass of the soil, so the mass of the solid plus the mass of the water. Remember, the mass of air is 0. It's the mass of solid plus mass of water. And then divide that by the total volume of the soil. So in this case, it could be, we could just sum the volume of the solids, volume of water, and volume of air together. But just to simplify, we'll call that capital V, the total volume of the soil. So this is the bulk density of the material. Another useful parameter to define is the dry density. Which is really just the bulk density with the mass of this, this water removed. So if we take the mass of the water out of it, we'll have the dry density. So we give the dry density the symbol rho subscript d. And that, if we just pick out the mass of the water from this equation, it becomes the mass of the solid divided by the total volume. So that's the dry density. Now, both of these are given the units of megagrams per meter cubed, so mass over volume. And we use the units of megagrams per meter cubed because when we turn that into a force, it becomes kilonewtons per meter cubed, and that's quite a useful unit for soil mechanics. So what do I mean by turning it into a force? Well, these describe masses over volumes. When we're looking at stresses and forces within soils, a lot of those forces and stresses are generated by the soil's self-weight. So it's quite useful to express this bulk density in terms of the weight of the soil. So if you remember your basic physics, the force is equal to the mass times the acceleration, so F equals ma. So to turn this into a force value, we need to multiply it by an acceleration, and in this case it's the acceleration due to gravity. So if we take the bulk density and we multiply it by the acceleration due to gravity, we get a parameter called the unit weight, or gamma. So this is the unit weight of soil. And we can also do the same thing for the dry density and get the dry unit weight. Now the reason why we put this in megagrams per meter cubed, because as if we multiply that by 9.8 meters per second squared, the acceleration due to gravity, the unit that comes out is in kilonewtons per meter cubed. And that's for both the dry density and the dry unit weight and the unit weight. And the kilonewtons per meter cubed is quite a useful unit in soil mechanics. So that's why we express the density in megagrams per meter cubed for the bulk density and the dry density. So from the three-phase definition of soils, we've been able to generate these 4 parameters: the bulk density, the dry density, the unit weight, and the dry unit weight.